Hey! What up, Charles? You are the first one there. Of course, I was a little bit late. I had a customer and they wouldn't leave, and I'm like, I'm trying to do it live here, and they're like, what's that? Well, actually, I think there were 12 other people here. You're the only one talking. So tonight I am finishing up Halloween masks. I guess when everybody comes picks these up, they're going to have to try them on to make sure that they're theirs, because I didn't... didn't write names in anybody's masks. They are 3D printed. So, I have to finish up 2, 4, 6 tonight. Yep. But they're really simple. All I gotta do is I gotta drill the holes, scrape the edges, and put the strings in. These are some of the masks that I did on the, I don't know if you caught the video I did yesterday, or maybe it was yesterday. I showed how I was doing these. I used Creality scanner, and then I used the scanner for the capture, and then bring them into Mesh Mixer, and then just do a plane cut to trim them. And it works really good. I mean, it takes about 15 minutes start to finish to capture, to have it be printing. And then these multicolors are done on the new Creality K2, which hopefully it isn't going to be too loud. It's going to be running, coming up in, I don't know, it's a couple minutes. I just started it, so. But hopefully it isn't too loud. If it is, I'll pause it. Yeah, Creality's pretty okay. They're pretty okay. You know, business-wise, they're a little different to deal with, but printer-wise, they're pretty good. I know I love my K1. I have a K1 that they gave me from last year, and I've been really happy with that. The K2, I'm still figuring out if I like it. I mean, so it printed glow in the dark today nicer than what the K1 printed it. 'Cause I already tried printing this one on the K1 printer. It did not like it. But on the multicolor print, so this is done off of the K1 or K2 with CFS. If you look at, I don't know if you're going to be able to pick it up, it's got lines in the Z every about 100 thousandths. Let's see. You can kind of see it, I guess, maybe. I know that on the Oni mask, you can really see it. Or at least in real life you can. There you go, you guys can see that. Yeah, it's got lines every 100 thousandths, which doesn't do it for me. But supposedly that's going to get fixed with a new profile and but yeah, everybody that's in the creator group that ended up with the machine has been experiencing the same kind of issues. Okay, so you asked that. Okay, so I get phantom limb pain. Okay, not like all the time, but enough that it's a thing. So, the camera's sliding down. Scotch, let me reposition you guys a little bit. So the other day, I was blind picking something up, just where you just reach and just pick something up, and the coolest thing you have your mental hands, what your fingers are in your brain, and it was the coolest thing. I went and I picked something up, and I could feel my mental finger being right here. It was the strangest thing, and I can't get it to do it all the time, but occasionally you can. You have to be like in the right mindset, and you can't have like your regular phantom limb pain going on. If it's really zinging, you won't be able to do it. But occasionally I can, just no look, and in my mind it'll be the same thing as just this. And I mean, that is just, it's amazing when it happens. So I have never done psychedelics. I have often, well, actually take that back. Under sedation, I've done ketofol, and that is awful. Ketofol was not my favorite way of being put down. So I how do I make cool stuff? I've always been a maker. My parents never had to worry about what I was going to do. I was always going to be someone that makes stuff. So I have a 4,000 square foot machine shop in Southern Oregon. And, before cancer, before losing my hand, I did ornamental iron and structural steel and automation and robotic pick and place assemblies. That's what most of my life was steel fabrication. And so I'm self-employed. No. So I can lock two, and I can lock two, and then I can, so I guess, yes, I can move selectively one. I am trying to. It is so hard because, there is not a lot of support or motion for this type of thing. The partial hand amputee sector of the world is just this kind of redheaded stepchild that nobody is really throwing money at or trying to do anything with. And it's tough. They do. They absolutely do. So what it really comes down to is return on investment. I've tried to basically give this away to Sir, and then limited to Arm Dynamics, and both of them were like, yeah, there's not enough ROI in it for us to take it and bring it to market. Because, for me to bring this to market through clinics to where it would be insuranceable and all that, it's going to cost me like $2.4 million. Well, I'm not going to do that. So I never have a problem getting through the airport. I even flying international, when I went and did the UK trip this year, I didn't have to take it off or anything. Thank you. And yes, I get the groovy reference. Of course, if you've been watching it for a long time, you remember when I made the chainsaw prosthetic too. Yep, that was such a waste of time. Oh my gosh, I ended up having so much time in that, and I made so little money off of YouTube off of that. I don't even think I paid for the parts to make that off of the YouTube money. That's right about when they were starting to monetize shorts, and when they started monetizing shorts, they cut the funding for regular videos. Okay, so Shark Tank would not be the ideal place for this type of thing. First off, because they take a huge percentage for like the next 4 or 5 years. They take like 5-6%. And where I'm trying to do this as an affordable DIY thing, it's just not the right anything. I'll be able to do it with that, huh? Right? Well, they wouldn't get it. I mean, they're into, got to make money and ROI and... I look like I have more than 5 years left. Oh, I don't know. I had chemo earlier this week, and it was so tough. And this was a good cycle. I mean, it was a long cycle. I had to do the zone meta along with regular chemotherapy, and that sucked. But what do you do? Two, 4, 6. Thought I had more than that. 2, 4. Multiple myeloma. It's a hematological that affects your skeleton, causes your bones to go away, basically. So I have a broken C2-3, 10, 11, 12, 4, 5S1, and then I have lytic lesions on my femoral necks bilaterally, and 10 where it's collapsed. That set of ribs is just kind of hanging out there. So that blows. Absolutely blows. Well, thank you. You probably send it to missingpartsclub@gmail.com. Ever since I started the trial, because remember, I still have this going as a device trial. I've been monitoring that email more often. So, right? Actually, right now, it's been my L45S1. And then bilaterally down into my hips. Bleh. Oh, it's been just terrible in the mornings. Just absolutely awful. So once the hand is loaded, so you don't with the prosthetic hand, you don't squeeze, because it's only as strong as what you are. But what you do is you pre-position the fingers, and then you apply load onto them. So and then it ultimately goes to how much weight can you support on the back of your wrist, because everything gets translated into trying to pull your wrist apart. I have picked up 120 pounds with this one. I haven't picked it up with this one, but the fingers are the same, so although this one is slightly more comfortable than what this one is. So I might be able to pick up more with that one than this one, just out of comfort. So I'm going to be making the device available for others, not the plans. And the reason for that is because I need the control on the device. When I go and make a modification, I need that to be implemented. Whereas if I just release it to the wild, the big problem with releasing it to the wild is, in plastic, it isn't strong enough to do anything. It has to be printed out of either mag aluminum or machined from aluminum, or it has to be, printed in stainless. But stainless is, I think, too heavy. I like the mag aluminum weight. it's a nice weight. But so I mean, with that type of thing, it wouldn't do anybody any good to just release it as, release the files. That, and I have about 10,000 hours into it that I would like to get compensated for. I mean, not to be, capitalist about it, but kind of a little bit. Oh, I was big into automation. I would throw a motor and a computer on anything. Okay, so when I did my trial video, I got a lot of pushback for, people going, well, you have too many restrictions on who you'd be willing to, put in your trial and who you'd be willing to sell the device to. And I'm like, well, I'm not going to sell the device and, put somebody's hopes up that it's going to work for them if their residual limb is wrong for this device. I mean, that would just be bad. I mean, that's lying to somebody essentially. And that's why I have the check socket, to where you download the check socket and make sure that your residual limb fits within this. Because if it doesn't fit in here, if it isn't a good fit, then it's not going to fit here. So, I just don't want anybody to spend any real money on it and then be disappointed in it. Because I feel that I have a responsibility for that. I mean, being that I am the creator of this device, I want anybody that is going to put the time and the effort and the money into building this, I want them to be successful in using it, and I want them to be successful in using it. I want it to actually, improve their life. It isn't, some of it is about the money, but it's not like I'm not making a pile of money off of each one of these that I sell. So another pushback that I got from, the comment section was, well, why are you doing it as a DIY where everybody's got to assemble it? And reason is twofold. Well, I guess it's actually three. If you spend the time to put it together, then you know exactly how every bit of it works, to where when you're out in the wild and you're using it and it breaks, you know how to fix it, which I think is the most important thing. The other thing is, it takes about 40 hours to go from the raw parts to a completed metal assembly. Well, okay, for instance, at the shop, I get $1.50 an hour. So that's $6,000 that we would have to add on to the cost of the $6,500 for the metal parts. So all of a sudden that takes this device, if someone does all of their own work and puts this together, they could put this together for around probably $8,500. By the time they get a vacuum chamber, a food sealer, vacuum composite stuff, some taps, some drills, all of that. But if they're hiring it out, if they hire out the machine work, that's going to be about $6,000. If they hire out the sockets, that's going to be about $5,000. All of a sudden it starts turning into $20,000, which still, for a prosthetic device, $20,000 is so cheap, especially for what this is. But somebody, Central America or wherever, less United States, $6,500, or even $8,000 US is a lot of money. I mean, don't get me wrong, $8,000 is a lot of money. But, if I make it to where it's available in its lowest cost form, I think I'm going to be able to help the most amount of people doing that. Where have you seen people with this device already? Because I mean, don't get me wrong, I don't care if somebody has copied this. I think it's awesome. If they are out there improving people's lives, awesome. I would like to see what they came up with. But, you know, definitely, no, I live in Oregon. I live in Southern Oregon. So, but if you've seen somebody with this, dude, I would totally love to see what they've come up with. Oh, you know, I should make a little printed cam lock thing for those. That's what I should do. So for shipping, so I have not figured out the whole import export taxation thing to like sell it to somebody in Canada and that type of thing. I've got a couple workarounds for a guy that I'm doing one in Canada with. So this design, well, actually, I guess it'd be the one before this one. I went from the rough idea to wearing it in about 4.5 months. And that's when I decided to take it from a project to making it into a product. You know, so I got rid of the grip pattern selector. I don't know if you remember, but like on the 150, what would it be, 158, 159 version, I had the 6 different grip patterns that I could, you know, lock and unlock the fingers. You know, it would do all closed, all open, pinky locked, ring pinky open, index. It would do 6 grip patterns. And I came up with this version because it's the most simple, it's the simplest design that I could come up with, and have it to be where I think that somebody else could put it together and be successful with it. Which, I mean, ultimately, that's the most important aspect of this is, you know, I want whoever's going to put the time, money, and effort into building one of these, I need them to be successful in that. But going back to why I'm doing it as a DIY, so if it's a DIY, I'm outside of the FDA and those requirements. So, but it has to be DIY, so I'm not manufacturing a medical device without proper licensure or clinic. Because if I do that, then that subjects me to a $100,000 fine per occurrence and 10 years in federal prison per occurrence. So that would suck. Oh, they totally do. So I'm actually working with, or I'm kind of working with this guy Chris from Point Designs. Well, thank you, Jason. That's awesome. So I'm working with the guy Chris from Point Designs. They make beautiful fingers, but they don't articulate. They don't move like these. You preset them. They got like a little ratchet, and they go click, 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 click. The medical system, for all that it is in the U.S., sucks. It is so broken. So recently, last year, Oser, Autobach, Arm Dynamics, they actually got a congressional bill passed to where a company cannot provide a prosthetic device to an amputee without going through a clinic. So everything that is a finished device has to go through a clinician in order for it to be legal and all of that junk. And the reason was because of Limitless Solutions. They who's the, I don't know, one of these inspirational people. He put a bunch of money into it. It's bugging me. What is his name? But anyways, they were doing too good in business, and Oser, Arm Dynamics, Autobox saw that, and they're like, every device they're selling is, one less device that we could be selling, and they're selling them for like $14,000, and we could be selling them for $100,000, and so they went and made a law. And I mean, I look at that type of thing, and it's just like that in its own is absolutely criminal. So if you did that, if you or named it a cosplay thing, that is called a rose by any other name. And any $2 attorney could walk right through that, because it goes by the intent, not by what you're calling it. It should be a crime. It should absolutely be a crime. I mean, but they passed the law all in the name of, patient protection and that type of thing. And it's just, so the problem I run into it is not only HIPAA, because that's where I'm running into the issue with the trial right now, is finding people that have the correct amputation, that are in the right time frame. Because I mean, the big thing is, once an amputee has settled in to the gear that they've decided they're going to use, it's really hard to get them to change to something else for gear. Like I have on my Patreon, one of my very, very early Patreon supporters is, his name is Moises Alejandro, and he, I think he's Southern California. He was out screwing off with his friends, getting towed behind a Jeep, riding on the hood of, he was standing on the hood of a car, or on a car hood, he was standing on, basically, being towed behind it, just land surfing. And he had the tow rope wrapped around his hand, and the tail of the rope got caught in a storm drain, and it basically degloved his fingers. Okay, so he is a he has the same amputation as me. Okay, exact same disarticulation at the metacarpal level. Still retains his thumb, all that. So he's been a brand ambassador for OSER for probably 10 years, 15 years now. And he is one of my, $25 supporters on my Patreon, and has been since basically the beginning. And I have offered him a device. I would build the device for him, and I cannot get him to go and trade, to wearing one of mine, and it's because he's comfortable with the device he's running with. And that's what I'm running into on so many of these other people. Once you get comfortable with how a device works, because, I mean, you have to learn how to pick stuff up. You have to learn how it feels, how the approximation is for, how to do it like a blind grasp. And you have to trust the device. Once you get to that point with something, it's really hard to want to change to anything else. Of course, I mean, like for myself, I couldn't imagine wearing somebody else's gear. I mean, I have an OSER auto or an OSER iDigits device. It was billed out at $85,000 to my insurance company, and um, who's the child abuser? I think I totally missed something. Huh. Okay, well, where is Seth the one that was doing the child abuse, whatever that I was ignoring? Bye, Seth. Sorry, dude. I don't get why anybody would come. I mean, my content is so milquetoast. It's not like I stir the pot on anybody. So why would somebody want to go and I don't know. I don't get it. It doesn't make sense. I am here to whatever. Anyways, where was I? No, no. I couldn't imagine wearing somebody else's gear. So I will be always, always wearing something that I made. And I think it's the same, of the other amputees that I know of, that I've met, because I build a lot of gear for people just local here. And really it's not often that I actually make a video showing it. I made that video where I made that little crab clamp for his name's Alex. He works at the Carl's Jr. that I go to lunch at pretty often. And I was talking to him, and it's like, hey, is there anything I can do for you to help you out? He's through the wrist disarticulation. And I'm like, yeah, I can build you whatever. So I ended up using a little bit of my Patreon money to buy the crab clamp, buy the Heim joint, make all the parts for it. But I imagine if he had the skills and the tools to do it, I imagine that he would be like me, that he would only wear his own gear. Nope, it is me. No, so it's me. I run my own machine shop. I have my own machine shop for the YouTube channel. I write my own scripts. I film my own stuff, and I edit my own stuff. I've recently started, I don't know, I wouldn't say collaborating with, but talking more to other YouTube creators. where I'm at in Oregon, there's not a lot of YouTube creators, so I'm kind of in this, I'm kind of in this little vacuum of Oregon, and there's nobody really to bounce ideas off of. So, but, I've gotten, I don't know, especially like on this Creality stuff, because, I don't know, we as creators were getting, jerked around by Creality so bad for the last, originally we were supposed to be making short content on the 18th. So then everybody did that. And then it was, oh, don't put it out until the 25th. And then it's like, well, only do short video content on the 25th. And you're like, well, do you want me talking about the printer or not? And that is just frustrating. So frustrating. Nope. So let's see. I have clinician friends, but they're more in the Midwest that I bounce ideas off of for how to get people interested in, wearing and using these. But I mean, that's tough, really. Like I said, it all goes back to what they're comfortable with and what they want to, what they want to wear. You're missing your last 3. Okay, so the real airhead. Tell me what you got. So you're missing your last 3 digits, like you're missing your pinky or you're missing your last 3 fingers. And then also where, do you still have your proximals, or proximals are the first bone. This bone. This is your bone. This is your proximal. This is your medial. This is your distal. So if you still have your proximal, there's a lot of options for you. And what I would suggest on that would be like a Nick's finger. Huh. I think my part of my thing has frozen. Because my last comment, I think my comments have frozen. The last I have is, do you have a team of people that you are working with on any end of your business here? I'm going to go grab my other phone and see what the other side of it looks like. Be right back. All right. So let's see what I am missing. YouTube. Let's see if technology is failing me. Ian Davis. Ian Davis is live. Okay. Ian Davis is live. Okay. Oh, yeah. Huh. Okay, so my comments on my other phone have frozen. Okay, so my comments on my other phone. Okay. Well, I'll just turn down volume there and I'll read comments from here. Okay. Yeah, yeah, it's stuck on like 2 minutes ago's worth of comments. Well, guess let's do it off of this one. Nope. It is stuck on, do you have a team of people to work with on any end of your business there? Do you have trusted folks to collab with or co-op with? Oh, I guess I could be doing it off my laptop, couldn't I? Right? Yes. The hand is strong and the phone is weak. That is technology failing you when you most need it. Yep, technology will always fail you when you need it the most. Yep. So, I don't know, who was it? Did the real airhead ever really say what he was missing? Yes. Okay, so what do you got going on now that I can read your text? Well, thank you. Yes, spurving bearings are in steep decline. They are so hard to acquire now, and a lunar wane shaft. Lunar wane shafts are so hard to come by now. I mean, I don't understand, why. They're in everything. And the dingle arms, you used to not be able to walk across the street without tripping over a dingle arm. But now, dude. No, so the best thing about this is it does not care if it gets wet. It doesn't care if it gets dirty. It will never run out of batteries. It's perfect. Okay, so real airhead, why don't you, let's see. Why don't you email me, missingpartsclub@gmail.com. And so if I were to sell them as a finished product, then I would be in trouble for manufacturing a medical device without proper licensure or clinic. And that will get me in a lot of trouble. So I'm trying to make it available without jeopardizing everything I've worked for and getting myself into trouble. And that's why I'm doing it as the DIY thing and kind of keeping it low profile too. Right? Totally. So that is what I'm going to be doing right now. Do you guys remember when I went to Europe earlier this year and gave a little talk at Maker Central in Birmingham, UK? And at the end of that talk, I was invited to apply for a grant through the OSV Fellowship. So write a bunch of essays, make a video, bunch of interviews, and all that. Well, I ended up getting the grant. So, but unfortunately, it's not like a grant. It's it comes in as taxable income, which kind of blows, because then I got to lose like 27% of the money on taxes, first off. But what I'm doing with that money is I'm running a device trial where I'm going to be able to fund the metal parts for, I'm hoping for like 16 devices, but it's looking like it might be like 14 or 12 just because of how things are costing. But that's going to get 16 of these devices out there. So, like that. Yeah, no, this is pretty cool. And I mean, and it's all mechanical. So anyways, I got that grant and I'm using it to, I'm going to be spending the money to basically improve people's lives. Running it as what I'm doing with it is I'm trying to decide if it's viable to try to market this as a DIY thing, or if really I'm wasting my time and I should only be focusing on doing it through clinics, which I don't really want to do because of the whole medical markup. Since I'm doing it off my other cell phone, I kind of need a cell phone holder. You would think that somebody would have printed one of those by now. But I really haven't. I have no cell phone holder. What the heck? Huh. I got nothing here. I got some tape. I'll do it with some blue painter's tape. So anyways, I'm trying to figure out where I need to go with this as a product, whether or not it's viable to, whether or not the market sector is large enough for me to, really for me to spend the amount of time and money and effort that it's taking in order to bring this to market. And it's tough. I think this is the coolest thing ever. But, I'm partial to it because, I created it. But I understand not everybody wants to wear this on the end of their residual limb. So, okay, so you say quick assemblage. You know why the springs are easily accessible right there? It's because when they break, you need to be able to replace them, like, on the fly. And, like, the other day, it was a ring finger spring. And I was able to fix my hand while I was having a conversation with somebody at lunch at Taco Bell. And I have to say, that was the coolest thing. Being able to fix your own gear. Oh, what is it about ATF? Right. Oh my gosh, that would just be awful. So, Okay, so the fingers are 3D printed in mag aluminum. And really, that's where it needs to go. The mag aluminum, it's a nice weight. It's a plenty good enough strength. I mean, as I've mentioned before in other lives and videos, you know, plastic just isn't strong enough for this device. You know, plastic's fantastic, but steel is real. And, you know, plastic just is not it. Oh, you say that. You do not mean it. Okay, so probably about a year ago, I made little flashlights that go into the ob-rounds on the medials, and you could use them as little pointy devices, and it worked really good. You know, that was also the time that I made little claws or something for the fingertips. I think I have some of those. I have those somewhere, probably underneath. So they are a thermoplastic, but what I'm using, Prusa was nice enough to donate, sell, give, donate or give, or do the creator thing, me one of their XL printers. And I tell you, they are so awesome to work with. Alan and Joseph are just super stand-up people. So I'm using ColorFab VariaSure TPU. That's which is actually a TPE, not a TPU, but whatever. And what I'm doing, because remember, I was trying to do the silicone with the overmold process on the fingertips, but I couldn't get it. So silicone doesn't stick to anything. You know, just silicone sticks to nothing. So what I was doing is I was making a 3D printed core that would actually click onto the distal, and then I was overmolding with silicone. So what I'm doing now is I'm using their toolchanger XL printer, and as you can see, there we go. I'm using 3 different types of ColorFab VariaSure, but I'm printing them at different temperatures. So I'm using their toolchanger as basically temperature control. So ColorFab, if it's printed at 190 degrees, then it's like regular 92A TPU. So pretty hard. And then if it's printed at like 220, it's pretty soft. It's about like a 70 Sure. And then if you print it at like 250, it's at like a 55A Sure hardness. So, but the neat thing about this is chemically, it's all the same material. So you don't end up with delamination to where the parts come apart. Well, thank you. Middle ring and hold up. Okay, is it possible to make only the middle ring and pinky fingers? Yeah. There's probably can't use his name. He's outside of Dallas. He was born amniotic band, so he had his natural pinky. And ended up helping him out making gear. So he didn't have index, middle, or ring. He just had his natural pinky. And I ended up helping him make some gear very similar to this, you know, for his situation. And it's mechanical. It doesn't do grip patterns, but it's basically the same gear. We just changed how the winder is. Yeah, so totally doable. Yes, I mean the new Prusa XL with 5 tool heads. That is an awesome machine. And really, it's the only way that I could make this type of thing, because, using like a K1, K2, like the Cheedy Q1, you can't vary the print temperature fast like what you'd need to do with this. So what I'm doing is I'm printing, the white only gets printed at 190 degrees, the blue gets printed at 220, and the black gets printed at 250. And I tell you, I am super close to having like it be just right. Like, I'm really excited about it. It's really cool. I've been making some pretty good strides in this, even though from my side of things, it sure doesn't feel like I'm making any advancement. But, and then also, so the last video that I did with, I think it was Fingertips 3 or something like that, I reached out to the company Recreus. I think they're someplace in the Netherlands. They make a filament called Filaflex 60 and then Filaflex, I think, 90 or 95. They are being so awesome. They are sending me a couple rolls of filament to try out for making the fingertips. So this color fab, even though it's awesome that it can vary the shore hardness, it isn't very grippy. So I run into the problem of I was experimenting using tackifiers. Okay. Hold up. Thank you. Happy Halloween to you as well. I am supposed to be finishing up Halloween masks, but I think I need to design and print a little string clip rather than tying all the little knots on the strings. So I'm going to do that after the live tonight. Hold up. So what it does, so the temperature difference makes a difference in shore hardness. So the part that's white, that needs to be relatively hard, and what that does is it keeps the parts on the fingertips themselves, on the distal phalanx itself. So you need that part to be really pretty rigid, but you need everything else to be soft. But you need it to be all chemically compatible to where it doesn't delaminate. That's ultimately where I was running into the issue with the silicone and the overmolding. Everything would work fine for a couple weeks, and then all of a sudden the silicone would just peel away from the core, and the outer portions of your fingertips would just flip, just peel right off. So anyways, that's where I'm going with the Recreus Filaflex 60. It's supposed to be, I think it's classified as a TPO. And that material is supposed to be stickier. Okay. No. Real airhead. So it all depends. So fingertips last all depending on what you're doing with it. If I'm doing machine work and I'm doing a lot of work on the plasma cutter and grinding and all of that, they wear out faster than if I'm just making videos. I mean, kind of like your fleshy fingers. If you're doing stuff where it's all kinds of abrasive and all of that, you're going to wear out your fingertips faster than if you're doing a whole bunch of nothing. Well, thanks. Okay, so, um, rubber, both synthetic and natural, there's a lot of process that goes into curing rubber. Most rubbers are cured using a sulfur steam injection process. Otherwise, natural rubber will just remain sticky forever. And that's not what you want, because sticky is just going to pick up dirt, and then there's no way of getting the dirt off of your fingertips or anything like that. So I'm looking for something that's actually tacky, not sticky, kind of like Post-it note. So actually, no, I don't. I am such a chicken. I have been stuck to the TIG welder before, so I will run the grinder with this hand, and it works good for that. But I won't weld with it just because it's conductive. I mean, that's just asking for problems. Welding with it. Yeah. So oh gosh, this was a million years ago. I was welding a access cover for one of the local utilities. It was out of like 3/8 aluminum. So I had, it was probably a 5/32 tungsten. I was pushing 300 amps. And it was like in the middle of the summer and high frequency, 300 amps. I was using like, gosh, 1/8 inch, maybe 3/16 filler rod, and I was standing on top of the pedal, just full bore, and I was, basically I was laying on top of the part that I was welding, and I stuck, and at that point, I'm, taking all the amperage, and I couldn't let go because the voltage was going through my arm, so I just had to kind of roll off the part. And that was the worst. Oh my gosh. My muscles hurt for days after that. And I mean, that job just sucked. But once you've done that once, you will. Hold up. Yeah, but so the problem with doing the gecko thing, okay, I've seen the gecko. I love the idea of it. In the real world, like working in a metal fab shop, the little gecko profile, it's super fragile. It's going to last like 2 seconds in a real world environment. The lifespan of it, and the amount of effort that goes into making it as a profile and making the fingertips. You got to remember, I mean, the fingertips are considered consumables. You're going to use them until they look ratty, and then you're going to throw them away. I was actually going to do that as basically a subscription model for the people that end up doing using my device. That, every, month, 6 weeks, whatever, their credit card is billed for $40, and they get a new set of fingertips in whatever festive colors that I'm doing, that cycle. Just because, I mean, they're consumable. They aren't a durable thing. So I need whatever I do the fingertips out of to be something that I don't get just a pile of time into. So, okay, so I'm glad you brought Cerakote up. Cerakote is literally 6 miles down the road. And they are going to be, Brian and Juan are going to be coloring up my next hand. The hand that I do on the demo trial for me. They're going to be coloring it up for me. So absolutely, Cerakote is going to be, they're going to be awesome. But I mean, they've been talking to me about doing this for like years and years. So I am going to be doing, let's see, Bull Shark Gray, Hunter Orange, and Armor Black. And so it's going to be, the chain and the drive is all going to be orange. And then we're going to do black and gray for the fingers and the links. So like the springs are going to be orange. This distal link is orange. Gray and black, orange on the chain, orange on the pulleys, that type of thing. No, Cerakote is not coat. It's a ceramic type paint that super high wear coefficient. It's powder coat is like pulverized plastic, and this is a ceramic paint that is baked and cured on. So not the same thing. Yeah, no, it sucked. I would not recommend being stuck to the welder. Awesome. Well, I'm glad you're enjoying it. Okay. So so everybody understands that it works by flexion and extension of the palm relative to the forearm, right? So it's this 54 degrees worth of motion that makes the fingers open and close 270 degrees, right? Everybody's got that, right? And the splay is abduction, adduction. So motion like this closes the fingers. Motion like this splays the fingers. Okay? Everybody's got that, right? And on this one, you go from the zero plane, zero, down, and that will lock and unlock the ring and pinky finger. Right? So it locks it in the open, unlock, and locks it in the closed position. Right? Everybody's got that. Okay, so the way that it works is this linkage that's on the top back of the wrist, okay, goes around this little pulley that's right there on the side of the winder and pulls on the winder core. That's literally the center of, oh, actually, I still have, I do. So the winder core is this piece right here. Okay, so as I go like this, it pulls on the winder core. Okay, so there's a whiffle tree right here and a whiffle tree right here. And what that does is it allows the fingers to move independent of each other. And you're moving them in pairs. But as you can see, I can just one or two or three or four. Okay, so you can distribute the load to the finger that has the least amount of resistance on it. And that's how all of that works. You know, that the power goes from one to the next, to the next, to the next. Okay? So with what you're doing here with the winder is you're literally just taking the chain and you're doing, let's see. Okay. You're literally doing this to the chain in the center. And when you do that, you're shortening the length of the chain, and that's what causes the fingers to curl. So you're getting 54 degrees worth of motion here to pull basically 1 centimeter 4 times to move all 4 fingers into their closed position. Awesome. Well, be sure to reach out to me on the email. It is number 15 miniature micro roller chain. There's one company that I found in the U.S. that sells it, and he sells it on Amazon. It's through Jeremy Newell Group. On I think one of the early videos with JLC, I listed it as a part. I can actually find that for you on this phone. I will find that part for you. There you go, Amazon. Miniature roller chain. Jeremy Well. There you go. $22.51 for 10 foot. No. So these fingertips do not work on my phone. And that's because I don't have them coated and clear coated with graphite. But if I were to clear coat them with graphite, then yes, they would. I wish that I had. Oh well. These tips are not conductive. But if I were to put graphite powder on them and then do clear coat or like a 3M77 over the top of that, then they would be capacitive conductive. So then it would work with my phone. But generally I hold my phone with my left hand and I scroll with my right. So it's a non-issue for me. Awesome. No, so I have a little 3D printed thing that's holding the phone on this little setup right now, and it's clamped to the edge of my table. It seems to be working pretty good. Normally I would have it on my camera rig that's off of the steel post that's behind there, but I have my Ronin RS2 gimbal on it currently, so I don't want to undo that. I don't know. I haven't thought about that. I haven't. Okay, so I just actually was talking to 3D Greg, because I know him in real life. Unfortunately, he's on the East Coast. I'm on the West Coast, but we text a lot lately. And we have been talking about doing a YouTube live together. We just need to figure out the time. So, I mean, that would probably be like a Saturday thing. That way, it's not interrupting his work, and, you know, we can do it early enough to where it's not screwing up anything for me either. But as far as, like, a real collab, I'm kind of in the middle of nowhere in Southern Oregon. There's really no other YouTube creators in this area that are in, like, the mechanical sector. I mean, I have, who is it? Rocket Man's here. Maddox. Robert Maddox is, he's in this area, but he and I don't have, you know, our channels wouldn't, you know, we have nothing in common channel-wise. I mean, nice enough guy, but, you know, that's not going to do so awesome on a channel collaboration. No, so what these are is the overtravels for the splay, so I can splay the fingers, and then so I can lock the fingers. So they have, so it's complex. So I'm taking one motion and I'm breaking it up into two functions. And so if you imagine a 0 point, so you have from the 0 point this way does splay, and from the 0 point this way locks and unlocks the fingers with the cartoid latch. So you need an overtravel in order to get either the splay to go from the fingers spread to collapsed. You need to be able to go past your end point to where the fingers are collapsed. And then for the cartoid latch, you need to be able to go from your neutral point to where it's engaging the latch. So what this does is it allows the center to not be able to connect it to anything. And to where you're from 0, negative is disconnecting the splay and only engaging the cartoid latch, and from 0, positive is disconnecting the cartoid latch and only engaging the splay. So I hope you get it. It was something that took a long time to figure out, is what it was. And once I got it, I was so happy. I was like beside myself happy about it. Well, thank you. I appreciate that. I wear either this one or this one every day. Every day, most days. You know, most of the day, throughout the day. If I'm doing a lot of typing or editing, then I'll take it off, just because it doesn't work super awesome for keyboard work. But I wear it, like, most of the day. Well, thank you, John Hyatt. You're awesome. So back to Cerakote. There is a product that they have called Micro Slick, and I will be having them coat all of the pins in microslick just to see how well it's a nano ceramic coating that is supposed to have super high lubricity. So I'm going to be doing all of the pins and the wear surfaces in microslick, and then all of the rest of the stuff just in regular Cerakote. But aside from that, I use PB Blaster silicone, and it works really good as long as you don't get like a lot of it on. What you do is you spray it on and you wipe it off. You want like barely a coating on there. Right? Yes. No, at some point in time it'll work awesome on keyboards. So I think that Cerakote is going to work amazing. I know for like I have a few firearms that are Cerakoted, and the awesome thing about those is you don't have to clean them hardly. You don't have to clean firearms that are coated in Cerakote. You don't have to clean like you do just like a normal factory firearm. And it'll be, so I don't actually have to take my hand apart very often, maybe once every 4, maybe 5 months. I mean, of course, it all depends on what I'm doing out at the shop. If I'm doing a lot of grinding and that type of thing, then I have to take it apart more often. But a lot of the times I can just blow it off with compressed air, and that works fine. Or my favorite is just brake clean. Just, hose it down with brake clean. You do have to take the fingertips off if you're going to do that, though, because brake clean will eat the fingertips, which, I mean, that's what it is. But it'll be really interesting to see how much easier it is to keep this clean and maintenance once it's been Cerakoted. And I think it'll be awesome. Alan Milliard. Let me write that down, and I will check out his work. Awesome. I will check that out. Okay, so, oh my gosh. So, proprioception. Oh my gosh, I spent probably a year on proprioception. And, so after actually, my gosh, it was longer than that. I tried it many different ways. So the way I was doing it, so, this was a couple different versions. This was like 3 versions ago. Same fingers, but it was a side quest hand. It wasn't one of my, like, main hands. I ended up adding back electronics, which is, like, totally against the big picture of this device. I ended up adding back the electronics so I could run an ESP32. And then I was running 4 HX711s, and I was running 4 load cells in the medial. So what I did is I used the wire EDM, and I cut the backside of the medial and put a load cell in this little void right here. And then ran the wires through the springs and then into the socket, and then all the electronics were on the form, which then I had to add a battery and all of that. So there were so many things that were against that part of the project, okay? So, but when you would touch here, it would compress the medial, boop, and then that would go to an HX711, which was the amplifier, and then I went to a 4-channel TENS unit, like an electromuscular stimulator, and then on the forearm cuff right here, boop, 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 I had pairs of electrodes to where when you would touch here, it would electrostimulate you here, and then here for the middle finger, here for the ring finger, and like here for the pinky. And then, you know, I had a little display because, you know, the ESP32 already has a display on it, and I had a couple buttons to where you could up and down the amount of charge you were getting off of it, or how much electrostimulation you were getting. And you know, after all of, because you have to adjust that depending upon the metal salts that you have in your body that day, because you're going to have different conductivity each day depending upon, you know, if you're dehydrated, or if you're, you know, if you have a lot of metal salts in you, or you're conductive or not. So anyways, science aside, you'd have to up and down the amount of voltage that you would get. So after all of that work, I used it for about a week, and I hated every minute of it, because anytime you would touch something, you're getting shocked. And, you know, what I had come to realize, like, early on, but I hadn't, like, really realized it, you know, it was something that you know, but you don't know that you know, is since this is a mechanical device, you already have proprioception from the amount of pressure that you're putting on your palm right here by opening and closing, the amount of pressure that gets translated to the back of your hand on the quadrilateral bone, the amount of pressure that goes right here on the radius and ulna, and the amount of pressure that goes right here on the forearm cuff. You can already approximate your proprioception of how you're gripping something without any complex electronics. So, but I ended up making it super complex, ended up, you know, added a bunch of electronics, and wasting a year worth of R&D, and it sucked. Because, I mean, I got to the end of it, made it work, and hated using it. It was like the 157 hand all over. I don't know if you remember, the 157 was the first version that I did myoelectrics for the control of the fingers, but it was mechanical for the actuation of the fingers. And the hand itself was beautiful. And the socket was, I did the socket out of red and black canvas, and it kind of had this Damascus look. I mean, it was beautiful. And I wore the hand for a week, and I hated everything about it. And I had probably 800 hours into this device. And basically I cannibalized the parts off of it and just threw the rest of it away. It's like one of the only hands that I got to the end, got it done, and then never wore. You know, like I said, I wore it for like a week, and it was awful. It so depressing. You know, you get so much time into those, and you're just like, blah. Yes, it's exactly like being tased every time you touch it. Anytime you touch anything, you're getting tased. But, okay, so then I also tried the, you know, the cell phone motors and then vibrator motors. And the problem that I ran into, like with the vibrator motors or the cell phone motors, okay, first off, you have to, the way you have to mount them, you mount them in basically like foam, you know, because the motors themselves need to vibrate, and that's how you're getting them to vibrate on your skin. So part of the cancer that I have what's called glove and sock. So during one of the 108 hours of continuous infusion that I did 5 times, it killed the nerve endings in my hands and my feet. So it always feels kind of like I'm wearing gloves and socks, thus the name glove and sock. So I could never get really good differentiation with the little cell phone or vibrator motors. Ideally you'd want it to be, you touch here and you'd be able to tell wherever it's vibrating, you'd be able to tell, oh, touching here, it vibrates here. Well, I could never get a good enough separation that I could go, with my eyes closed, oh, this is my index, this is my ring finger, this is my pinky finger. And it became just something that, again, after a pile of work into it, was something that wasn't something that I needed in the first place. It was, I don't know, it was awful. So mechanical position, so I tried the little pokey wire thing even. And the problem with that is you don't get enough travel. The amount of squish that you're getting here doesn't give you enough poke here for it to be something you could really tell. Because then it's like, well, what is your baseline of getting poked, and then what is it, that I'm really getting poked? And then I tried, but then it's, force over travel and that type of thing. It waste of time. So 7 fingers. I know you saw the video with the alt limb project and they put a thumb on the pinky. The problem is there's no actual real world use for it. This modern world is designed and developed to be interfaced by humans with 4 fingers and a thumb. So having something that isn't 4 fingers and a thumb means that you don't interface with the world efficiently. So there you go. Well, I don't spend a lot of my time in the orchard picking apples. And it wouldn't help me turn any dials on the milling machine or the lathe, so. But you're more than welcome to print yourself up and alt thumb and strap it to your hand. I would not want to hold you back. But then, okay, so going down that rabbit hole, how are you going to individually control that? So then you end up having to either wear a belt harness, or if you're going to go myoelectric, then you end up having to do solar plex mounted EEG or EMG sensors to wear a finger. It becomes just a whole thing that, it's cool for the novelty of it, but it's just novelty. I mean, it's the same thing as people going, oh, why don't, if I had your thing, I would have a sword like Assassin's Creed on my arm, and I would this and that, until you realize, oh my gosh, that's an extra 3 pounds that you're packing around all the time for a knife that you're never going to extend out in public, because if you did, you would go to jail. I can do this. I can do that. I can lock and unlock my ring and pinky finger. That's pretty cool. But actually, moving fingers individually, if you really think about it in the world, how you interact with it, it really has no value. Being able to go, like this, or, like this, there is nothing that you're going to do this that actually has value to it. So, why set up a thing mechanically to where you can do that? That's something that I really learned when I moved it from a project to a product, is you need to scale and become very efficient with both the mechanics of it and the motion of it. Even like with the ring and pinky lock with the cardioid latch, I keep going back and forth as to whether or not this has enough value to actually be included in the device. I mean, sure, for novelty, it's amazing. I love it. But as far as the complexity that is involved with having it be able to lock and unlock the ring and pinky finger, because I can lock it either in the open or in the closed. I don't find that I use it really all that much. I mean, it does have certain applications, but even say like the most used grip pattern is this one right here, where you rest the bottom of the cup on your pinky, and what that does is it keeps the cup from falling out of your grasp, and then you don't have to really grab the cup very hard. This is really the most used grip pattern. But you do that all by positioning the cup when you do your acquisition. So it's like this. It's really cool, and you'd use it for precision tripod grip, and for that it works awesome. But in the same, I could just position the hand differently. Oh, absolutely. Hold on. Right? Exactly. Absolutely. Function first, then form. Oh my gosh. I have, so I do consulting. I mean, as part of the machine shop, I do consulting. And oh my gosh, people get caught up on form first, then function. And it's like, no, you need to have it actually work first. Then we can come up with a box that it goes into. It's like I'm working on this project for this group. They're in the other end of the world, and they had this. Their project was all nicely packaged up in this organic shape, but the project itself didn't work. It didn't form. It didn't actually function and do anything that it was intended to do. But it was in this super cool box. And I'm like, if it doesn't work, it has no value. And they got super twisty about it because I was killing their dream as far as, they wanted it in this really cutesy little form factor package. And I'm like, it has to work first. So I appreciate you saying that it is. So yeah, absolutely. So that's something on this version that I was able to do. So actually, where holy cow, I don't have a fork. This setup works so good for holding utensils. like knife, fork, spoon, that type of thing. This setup works so good for that. And it's because of the, actually, I have to say, this one works just a little bit better. I need to remake the forearm cuff of this one because this forearm cuff doesn't allow my hand, my palm, to seat far enough in like it should. So I don't get the crossing of my thumb to my medial. But on this one, I do. What that allows you to do is use okay, hold on a second. Okay, so big thing on myoelectronics. Okay, they're incredibly fragile. I have a video of me picking up 110 pounds with this. You could never do that with an Oser Autobach or an Oser iDigits Quantum. You know, it would be broken, all kinds of broken. The second is speed. So this one is as fast as my natural hand. Okay? A myoelectric hand is 1 second to open, 1 second to close, which is incredibly infuriating to use. I mean, it is so slow. And it has to be because, like, say, for partial hand amputees, the motors have to be housed in the proximal section of the finger. Okay? Well, that means it's a 1/2 inch diameter motor. You know, then you do the whole Ohm's law and, VIR, a motor that's a 1/2 inch diameter can only have so much torque. So then you're trading speed for force. You know, you need to be a usable amount of force, but you want it to be fast. So you can either have it be super fast, but have no torque, no grip force. Or you can have all kinds of grip force, but it's going to be super, super slow. And, there's a little bit of room for variation in that by upping your voltage, but then you have to deal with heat and thermal loss. Okay? So, you got to figure, the more, say if you're upping that with voltage and current, then you need to run bigger battery packs. And then your batteries are going to die sooner, and, that side of things, just bad. So, fragile, slow, and not very strong, and incredibly expensive. So, my Oser iDigits Quantum was billed out to my insurance at $85,000. This device, if you hired it all done, so you bought the metal parts at $6,500, you paid a machine shop 40 hours, about $6,000 to machine all the parts, you had a clinician go and make your sockets for $6,000, $7,000, you're going to be in this device $20,000, which, that's 25% of what what an Oser iDigits costs. And you would have something that you could actually work with, that you could actually, that would actually survive a day in the real world. So that is why body-powered mechanical is better than myoelectric. Okay. Right? I know. So when I was living in hospital and they were removing my fingers one at a time, because remember, that's how it happened for me. So it was within my 100 days after my autologous stem cell transplant. So I didn't have an immune system. Because of my low bone density from multiple myeloma, I had fractured and shattered the proximals of my left hand. And they pinned my fingers, and everything was looking great until I got a blood infection, bone infection, septicemia, gangrene. You're going to die. So then they took a finger off to lessen the infective load. And then they sent me back home, and then had me come up for a checkout, for a checkup. And then it was, man, you are not looking so good. Don't plan on driving home. You're scheduled for emergency surgery tomorrow. So then they cut another finger off. And then go back home, come back up. God, man, you're not looking so good. Don't plan on going home. Emergency surgery tomorrow. So then they cut another finger off. And, and now at this time, we're starting to get serious. And then it was, man, you are not healing anymore. We're just afraid you're going to die. So it's like, this will be your last surgery. We don't know where we're going to stop, but this will be your last surgery. And you're like, what does that mean? And they're like, well, we're going to figure it out. So thankfully, they left me my palm and my thumb, didn't just cut it off at the wrist, because that would have been all kinds of depressing. But, again, not the path I'm on. But, yeah, so it was awful. But when I was in hospital, as they were amputating one finger at a time, I spent all of that time figuring out how to write with my right hand, because I was left-handed before that. So, and my handwriting is still terrible, but it's that one is at home on my serial killer wall of hands. The two-finger Ninja Turtle one is... I have most of my old designs are all mounted on a wall outside of my office at home. Oh, yeah. No, this is awesome. It's as fast as my natural hand. I wouldn't imagine doing it any other way. So the big thing that I'm trying to do is I'm trying to get people to bootstrap for themselves. No, I had chemo on Tuesday. So, I don't know. We don't call it remission. I'm just in this holding pattern. I have to do chemo forever. So the cost of staying alive is 9 hours of chemo once a month. And then you feel like garbage on Wednesday, you feel better on Thursday, and by Friday you're kind of back to normal. So, yeah. Oh, do I find the ability to use wrist flexion and extension crucial? Okay, so I have, I don't know if you've seen my videos for Mark. I only have a couple on the channel. But I made him a set of golf hands, and then I made him a set of guitar hands, because he was a musician before he got PID and sepsis. And, he has myo hands, and, they spend more time getting repaired than they do helping him in his daily life. And I know so many people that is kind of the case. They have these super cool robot hands, and they're always broken. They're either broken or the glove part of the fingertip is all torn up and looks awful. or the batteries are dead, or they need new batteries, or they broke a wire, or whereas if they were just mechanical, so much better. So I've made a couple bifurcated hook, the split hook stuff. What I tend to do is I make more purpose-driven, purposeful devices. Like I made for this one kid, he was like super into rock climbing, and I ended up making him a cam lock to where he could crack climb. He puts his end effector in like a crack, and then he rotates his wrist, and that would expand the cam inside the hook, and it would just cam into position, and then he could pull against that, and then acquire here, and then rotate and back and in and twist and pull, and it was super cool. And he uses that all the time. And then for like Alex, the kid that works at Carl's Jr. where I go to lunch, I made him, he wants to do landscaping, so I ended up making him this little crab clamp swivel thing to where he can hold on to a shovel, because he was using a split hook and he could never get a good enough grasp on the shovel using the split hook, because it's only rubber band powered for that. Whereas on the crab clamp, he can just, clamp that down super tight, and then it's actually attached to his residual limb. And he says that works out so good for what he's doing. Oh my gosh, missed a bunch of that stuff. Absolutely. Awesome. Well, thank you. I appreciate that. Chemo does suck. Chemo is awful. I'm sorry you have long COVID. That blows. Yeah, I've been, one of the things that I miss, I was never free climbing, like out in the wild, but I loved gym climbing, and I miss that, missing my hand. I've been gonna, one of those make a little cleat type hand. I've been gonna do that for years, just so I can try it out back in the gym. And it would just have, it'd just be like a little close hook to where you could just, and I don't know, someday I'll do it, and that would be awesome. Someday. You're welcome. So of course I'm using volunteer closing, and that works best for what I'm doing. I couldn't imagine running a backwards hand, and I would. So I don't know. I think on a split hook, I think on a split hook, volunteer opening has its benefits on a split hook, but then you're limited to how hard it's gonna grab a hold of anything, because it's only gonna be as strong as the 2 or 3 rubber bands or the spring or whatever you're using to have it close. So I think it really actually depends on what you're doing. Yeah, I don't know. I think it would all depend on what you're doing. For me, I would always do volunteer closing. Because like on this, it's as strong as, this device is only as strong as what you are. Whereas the other, you're reliant on the rubber band. Oh, totally. No. But I mean, like what I'm finding out in the trial, in trying to get this trial off the ground, is, not everybody likes this aesthetic. And while I'm like, oh, it's a super awesome aesthetic, a lot of people are not that way. Which is fine. I mean, not everybody has to be driving, black Model T, black Model T Fords. But, that becomes a thing. I don't know. It's cool. Yeah. So I don't know. It'll be pretty cool. It'll be interesting to get the trial going and actually start getting these devices onto other people. I'm hoping that this device trial really, first off, I'm hoping that it's successful. That's ultimately the goal. I want to be able to help, rebuild 16 people's lives. Hopefully I can make the money stretch that far. That's going to prove to be a little bit difficult, but I mean, that's the goal of it. Because rejection on upper limb prosthetics is huge. I mean, the rate of rejection is, over 50% for people that, they get a device and then they stop using it throughout some point of it. And I get it, with a partial hand, it kind of has to become part of your persona. If you were missing a leg, if you were below knee or an above knee amputee guy and you were wearing pants, you'd just be a guy that walks with a limp. But missing a hand, you walk into a room and everybody knows that you're missing a hand. So, you have to be okay with that. It has to be kind of your thing. So, let's see. No, so I wouldn't add. Really, there's nothing for things to get really caught into on this device. It's pretty, it's pretty smoothed over. There's not a lot of places for this one to get caught up. I do have to take it off to take off a hoodie or to put a hoodie on, but aside from that, I can do, I drive with it. I drive with it. I don't generally take it off out in public. I've never had a problem with it, really. So, when you have an amputation, there's a period of time during the healing process where you actually can't wear anything over your residual limb. And that's for the scar to harden and for the nerves to settle down. If you start trying to wear something over that too soon, you'll actually cause trauma to the scar site and cause keloiding. And then you'll also cause nerve damage. And what that'll do is, because of the traumatic response. It'll cause overgrowth of the nerve ganglions, and it'll cause you more phantom limb pain. So they really encourage you not to do really anything during that period of time to heal. But after like 6 months, 6 months is about the earliest that I've ever worked with anybody for building a device. And I'm doing that actually right now. I'm working with a guy that's, well, he's like 7.5 months now. But when we first started talking, he was 6 months. Um, and even like right now, his scar site is not truly healed enough. But what you're also doing is you're waiting for your residual limb to reduce, because, after it's had its traumatic, event, it's horribly swollen. So, if you were to go through the time and effort to build a socket right after your amputation, it's not going to be near the socket that it would be, 6 months or a year after the amputation. I mean, I know that, like, when I go and I put on, like, the red or the blue hand, like super early hands, these are 3D printed hands, they don't fit for nothing. And it's because, that was during the time that my residual limb was still slightly swollen. So, now it's pretty much become a size. But, during the time that I was still developing stuff, um, sockets that fit great back then don't fit for anything now. Well, thank you. Thank you, Neutrino. I appreciate that. Um, so this device is only for a hard socket. A couple reasons for that is, with a hard socket, you know exactly where your hand is going to be position-wise to where when you pick stuff up. So your ability to acquire things, even to blind acquire something, is way better with a hard socket as opposed to a silicon socket. Second, silicon is gross. You start sweating inside your socket, and it is absolutely gross. It's kind of this swampy, kind of sloshy feel to it. Yeah, just awful. Um, and then also where I'm using lateral motion, along with flexion extension, if this doesn't have a kind of a pretty tight feel to it, what that's going to do is it's going to allow for excess motion of your residual limb within the socket, and that's going to cause callus, it could cause sores, and damage at the scar site, that type of thing. So, this needs to be, kind of a snug fit, because I'm using the lateral motion, the abduction, adduction. Hope that helps. No, it's exactly like that. But then what you have to deal with, remember, that's a scar site right there. So you're already, kind of prone to skin infections there. And especially like for somebody like me with a compromised immune system, last thing you want to do is get, you're sweating into it, you get some bacterial growth, and now all of a sudden you have, some skin infection that then goes, internal, then you get sepsis, and, now you're back onto, thinking about dying. I mean, that's not cool. Yeah, ew. Just ew. Okay, Open Bionics. Is this Joel? Is this one of Joel's engineers? Um, okay, so each one of these hands, each one of my designs kind of works in the same fashion. I've kind of landed on a set of functions and, like the endpoints. Like all of my hands always end, being in a straight line with your forearm. And you do that, so it's predictable how you acquire things and pick things up. The other reason is because, that's where you have the greatest amount of strength, is when you do the lockup, that it's straight. If you were to lock up like this, you don't have really any strength here. Sure, you're using more degrees, to get the fingers to move, but you have no holding strength here compared to here. Um, so really now I'm in my design where the endpoints are, they all kind of feel about the same. Uh, it's like the endpoints on this one are different than the endpoints on this one, so they do feel a little bit different. And then also, this one where you can lock and unlock the ring and pinky fingers, um, that has a different feel to it. But they all kind of feel about the same. So as far as needing time to go between the two, you don't. Or at least I don't, now that I've been, you know, wearing this style of gear for as long as I have. Um, so when I was, okay, so why did I come up with the idea of making my own hand? Because what was available on the market sucked. You know, for partial hand, there's hardly anything that's really available. And what is available on the market sucks. Um, so, like for disarticulation at the metacarpal, no proximals. Um, Point Designs makes an absolutely beautiful finger, and and they're pretty strong, but they don't move. They aren't wrist driven. They aren't body powered. You pre-position them. They're on this little ratchet and pawl, and you go click 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 click, and you pre-position the fingers, and then you use your thumb to grasp against, which is cool. Don't get me wrong. Okay, but I like the whole body powered and having it move. Um, but I mean, Point Designs fingers are beautiful. Um, they're expensive, but they're beautiful. Um, so aside from that, you're either going to do a Point Designs or you're going to do an Oser iDigits Quantum, which is a myoelectric hand, and that's incredibly slow, expensive, and fragile. So I needed something with what I do. So I mean, I still run the machine shop. I still run the machine shop. So I need something that is strong and reliable and durable. So since that wasn't, in the marketplace, I am trying to fill that void. Where I'm meeting resistances, getting it out there, and where I'm having to do it as a DIY thing, just out of legality, that is some resistance. But again, I'm trying to do it for as cheap of a solution as I can for people. So there's some pluses and minuses off of that. Hold on. Okay. So Joel, in what, June, he came out with his um, body powered partial hand solution. So it does not splay, so it's fixed fingers, and his end position is here for the fingers being closed. Um, it's out of plastic, so there is a lot of flex when the fingers lock up. Um, Another thing, I believe you can only pick up like 20 pounds with it. So it doesn't have a workable rated load for what I do. Um, I looked at them. I mean, it's, I have recommended that device to several people. Just to, I think that Joel's device would be a better fit for you than what my device would be. I've recommended it to several people. I hope that he is doing the same with mine, but, I don't know. But, I don't know. I spent most of a day at their headquarters in Bristol and showed them all about mine, and we talked about where they were going to have issues with theirs. Nice enough group of people. Their design could use a lot of help. And I don't know whether or not they decide to take the design offerings, the design solutions that I offered them, is kind of still yet to be seen. We'll see. So hold on. Okay. Well, thanks, Sean. I appreciate you watching my live. Okay, so some occupational therapists are. Others are really resistant to it because, going on to the next question, do I think that prosthetics industry will ever improve? Unfortunately, I really do believe that any change that comes to this market sector is going to have to come from within, like what I'm doing. So the innovation is going to be driven by the users. The best clinician in the world, unless he's missing parts, is never going to know what it's like to wear a prosthetic device on his residual limb. And that's part of the reason why I want to teach people how to make their own sockets. Because, you could have a guy that, he's the best of the best at making a socket, but he will never know what it feels like to wear it. So, if I can teach someone how to modify and fit and trim, then, you as the end user, you go, oh, it would be really nice if this area were a little bit tighter. So I teach you how to, modify your socket to where you can get the perfect fit. If it's a little bit tight here, it's rubbing a little bit. I teach you how to do it, then you can open it up. You get the fit that is perfect for you. And you have, all the time in the world to be able to dink with it. Whereas a clinician, they want to get it all done within, 6-7 hours. 3 fittings, is what they want to get it all done at. Well, you have to wear it every day. So if it's like, oh, if it were just a little tighter here, a little bit looser, you are going to be the one that is the most impacted by how it fits. Your clinician may love you to bits, but ultimately it's about a paycheck, and he doesn't. I mean, he cares, but he doesn't really care like you do about how it fits. So if I teach you how to do it, you'll get a better fit. And then also, on the channel, I get inundated all the time with people going, I'm missing this. I'm missing this combination of whatever. You need to design something for me. And my answer as of late to that is, well, what's keeping you from designing for yourself? Because, much with my case, you're going to be the one that is the most impacted, if you design this whatever. And with the age of 3D printers and the accessibility and all that, it's super easy. And then even like with the companies like JLC and PCBWay, You know, if your design requires that, you know, it's metal 3D printed, you know, that's sending off a set of step files, and then in 2 weeks you can have the metal parts. So really, there's nothing holding you back from being able to design gear for yourself, rather than waiting for, oh, sir, Arm Dynamics, Autobach, whoever. You know, because Autobach and them, you know, their big thing is there isn't enough return on investment for them to go and design, develop, you know, a device or a set of devices for, you know, a small group of people that may or may not choose to adopt this brand new device. You know, it's like, you know, that's part of what I'm running into with this. You know, I think this is the coolest device, you know, for partial hand amputees. But a lot of people, you know, don't want to wear this. You know, it's too industrial, or it's too steampunk, or it's too something. You know, it doesn't, you know, it brings too much attention to you. You know, and it's not their thing. You know, so, you know, that's what they're afraid of. You know, Oser, Autobach, Arm Dynamics, you know, as far as should we go and put a bunch of money into a device that, you know, end users may or may not end up using. So that's a huge thing for why I don't think that, you know, industry itself is going to change. There's no incentive for them to do it. You know, it's all risk. You know, there's very, very little upside for them to, you know, innovate and bring new devices to market. Um, I don't know. So back to the Open Bionics, there's a study for lower limb amputees that if they do the shell around for like their calf muscle and their calf of their leg, that there is better. There is a mental connection. I don't think that you have the same thing, or at least you wouldn't have the same thing for a partial hand device like this. I mean, maybe for uh, like a transradial or a through the wrist amputation, but really, I think it's purely for an aesthetic thing. I don't think that it has any real psychological benefit aside from, you know, it doesn't look like this. Even though, I mean, this is the aesthetic that I was going for my device. I like the industrial, technical, cyberpunk, steampunk look. Um, you know, I could absolutely make a cover for this. It would just, for me, it would just be extra weight and something to get damaged. You know, for me. Thanks. Right. Right. Yeah. No, they want to get it done in a couple 1 hour visits, and that's it. And you know, you'll get way better service out of the small clinics, the little mom and pop clinics. Uh, but you know, so my machine shop, I do mostly job shop stuff. Uh, Somebody brings me an idea and a Taco Bell napkin, and then I can automate. I can prototype it, develop it, design it, and automate it for you. I can go from concept to finished product, basically. I also do, you know, repair work. Like I'm doing a dentist's chair arm right now, fixing a place where the little lamp has broken off. So I got to fix that tomorrow. But you know, I just kind of just do, you know, all around stuff. I do not do engine machine shop because that's a completely different world. You know, I do my own engine machine stuff, but I don't do it for other people. No. So I don't have issues with it getting. That's the beautiful thing about a mechanical device. It doesn't care if it gets wet. It doesn't care if it gets dirty. It never runs out of batteries. Um, you know, before I went and did my on-site for OSV, it had been 5 months since I had taken apart and cleaned it. Which is totally awesome. Um, okay, so the metal parts of this device are about $6,500. If it takes about 40 hours to refine it and to fit all the parts, so um, so this is part of why I'm trying to do it as a DIY, because it makes it as affordable as I can offer it as a device. If I'm putting 40 hours of work into refining it to put it together, I'm going to charge for that. So you have the $6,500 for the metal parts, then you'd be adding $6,000 to put it all together. And then if you're hiring out the casting of your residual limb and the sockets and all that, expect to spend between $5,000 and $7,000 depending upon your clinician. So all about 75, $8,000. So that's part of why I'm doing it as a DIY thing, is because it makes it as cheap or as inexpensive as I can in order to get these to as many people as need them. Oh yeah, no. The the medical markup is absolutely stupid. No, if I was okay, so this is part of the disconnect. If I were to have to run this through clinic, then I would need $4 million E&O, errors and omission insurance, which costs whatever it costs, $15,000 a year. So then I have to amortize, I have to expense all of that out, and I have to front load that. So I have to pay that 15, 20 grand before I've sold a single one of these devices in the year. So I'm taking a huge risk. you know, and you have the medical markup, and then clinicians get kickbacks and all of that. It's a horrible system. Um, it's it sucks. It is crooked. There's no reason. Well, okay, so then going down that thought, so Medicare, because people in the U.S. are, I hate to say entitled, but um, we figure, oh, I've had this terrible, and I've lost my hand, my leg, my whatever. I'm owed a prosthetic device. So you know people don't want to spend a bunch of money on a prosthetic device, even though it's going to improve their life. Everybody looks to what the insurance will pay for. Oh, insurance will pay for this, I'm going to go with that. So on a mechanical device, Medicare kind of sets that standard. Medicare will pay $15,000 all in for a mechanical device. Now, if it were a myoelectric device or a computerized thing, they'll spend $100,000 on it. Okay, and that's because, Autobaco, sir, they've done the lobbying, they've gotten the expense tables modified. So, Chris from Point Designs is using my use case as an example of why there needs to be reform on the Medicare tables for insurance. But even then, even if they were to double it, so that's $30,000, you could build this device, but there are a lot of other devices that you wouldn't be able to do that. But that would be better than nothing. But then for me to be able to do this through clinic and be able to offer it and advertise it, it's going to cost me $2.4 million. through as a Class 1 FDA device through, get it through review and, oversight committee. And then once I do that, then I have to carry my E&O and all the insurances and all of that. Whereas if I offer it as a DIY thing, then you, the end user, are accepting all of the liability and the responsibility. And then I don't have to pass that cost on to anybody that wants this as a device. Let me get caught that up. Right? Yeah. No, so for cleaning this, I generally hit it with a can of brake. I pop the fingertips off. I hit it with some brake clean, and then I hit it with compressed air, and that generally works amazing. Right. Well, the reason why they don't cover upper extremity prosthesis is because there's a huge rate of rejection. It's most people that do upper body, upper limb prosthetics end up rejecting them. Right. Okay. So you say that. When I lost my fingers, I applied for Regents Blue Cross Blue Shield to buy me a prosthetic device, and the letters that I got back from them were, fingers are considered a luxury. And, it took four appeals to the state, 4 appeals to the insurance company, then an appeal to the state. And because Medicare would cover it, then private insurance had to cover it. But initially, they weren't going to. Well, why? So, hand crank potato peeler. Yes. Yes, exactly. I'm doing it as a DIY thing to sidestep the FDA and the requirements for FDA approval, oversight, and regulation. Yes, exactly. Brake clean. Brake clean and compressed air. Just be sure to take the fingertips off first, because brake clean will eat the fingertips. So it all depends on what the add-on, what the new pieces are. If it's something super complex, I may 3D print it. In reality, I'll probably just, do it all in CAD, and I'll throw it out on the CNC milling machine if it's something simple. If it's, a complex assembly like the cartoid latch, then I'll 3D print it a couple times. I'll get it to where it just about works, and then I'll go and throw it all in metal and just make it work. So the fingertips are, right now, they're ColorFab VariaSure TPU, which is actually a TPE, not a TPU. But yes, they're a rubbery type thing. I'm currently waiting for a filament called Filaflex from company Recreus, and it's supposed to, I think it's a TPO, and it has a higher coefficient of friction than what the TPE does. So it would have, better grip. So right now, XYZ, I am starting a device trial with this device. I applied and got some grant money, and that's going to allow me to run 4 trials. Well, it's potentially going to allow me to run 4 trials of 4 devices each, so I can see if the DIY of doing a prosthetic device is a viable method of getting it, out to people that need it, or if I'm just kidding myself. So yeah, right now I'm doing it as a device trial. The first step to that is you go to Printable's website, you download the check socket, you make sure that your residual limb fits into the check socket, and then you send me some pictures of it, of your hand with the check socket on there, and then we have a conversation about what your skills and abilities, and want to make sure that you can afford to have the sockets made, or that you can make the sockets to where everybody's going to be successful. Because it's $85,000 to prepare the paperwork in order to submit the filing to the FDA. And then it's $2.4 million to file the device with the FDA. And then once you file it, as long as the device is going to be available to market, it's going to be about $24,000 per year to maintain the errors and omission and product liability insurance for the device. So yeah, it's all about money. Remember, I still have terminal cancer. I'm not going to put $2.4 million into anything. No, you could not call it something else. That is termed as a rose by any other name, and it goes by intent of the product, not by what you call it. You could call it Susan, but it's still intended to be a prosthetic device, and that's what it, But whereas I'm doing it as a DIY product, then the end user they're responsible for the assembly. All I'm doing at this point would be selling them a collection of parts. They're putting it together, they're determining suitability, they're, building the sockets. The end user is accepting the responsibility, not me. So, and that's, and that's why I'm doing it the way I am. Well, it's all about money. FDA is really nothing more than a lobbying group. And it's terrible to say it, but that's what it is. Right, no, and I mean, I could see it, I could see, the regulation and the legislation for DME if it weren't, if, if there was really risk of someone being damaged. But for something like this being a class 1 medical device, there is really no real reason or need that I should have that type of oversight. I mean, technically a walking cane, walking canes, that you see at, Walgreens or whatever, those are under the jurisdiction of FDA. If, whoever's manufacturing those, they should be, they should have their class 1 certification on those. Now, however many people do or don't, not my thing, but, everything is under the jurisdiction of the FDA. And if you look at what your repercussions for running afoul of the FDA, it's pretty steep. Like, for if I was convicted of manufacturing medical devices without proper licensure or clinic, it comes with $100,000 fine per occurrence and 10 years in federal prison. Now, being a federal charge, there is no bankruptcy, there is no getting out of it because it's federal. So that's why I'm doing it as DIY, and trying to be as low key about it as I can. Oh, I'm not starting a prosthetics company. What I'm doing is I'm offering a product. I am not a clinician. I am not a prostheticist. I am a machinist that gets it. And that's all that, yes, as in the US, I don't know where you're based out of, but in the US, if you start calling yourself a clinician or a prostheticist and you aren't certified and you aren't licensed and ticketed or whatever, you can actually get yourself in a lot of trouble for that type of thing. So, if someone were to hire me to put this together for them, they wouldn't be hiring me as a prostheticist or a clinician. They're hiring me as a machinist, to fit and finish the metal portion of the device. I can't make somebody's socket for them because I'm not a clinician. There's some pretty sticky rules and laws that go in place on that. Well, so the thing is, there's no, nobody is stopping, there's nobody stopping me from building myself a prosthetic device. The problem comes in when I offer to build it for somebody else and I am not licensed and insured and, and I'm not running an FDA approved clinic. That's where the legality goes in. I can do for myself all I want, and there's nobody that can oversight that. And that's the loophole that I'm exercising for my project. I am selling you a collection of parts. Whatever you choose to do with that is up to you. But you are responsible for determining that it is suitable for your needs, and you are responsible for putting it together in a fashion that is going to meet your needs. I'm not selling it as a finished prosthetic device because I'm not a clinician. I'm not a prostheticist. I am a machinist. Awesome, Timoth Maximuth. I appreciate you being in here. I hope you have learned a lot. But you see, that's the, okay, so XYZ, that's the difference between UK and US law. So I've run my plan by several people, even people within the industry. When I did my UK tour, I met with Hugh Gill, who is the director of R&D for OSER in Scotland, and he loves the device. He thinks it is far superior to what OSER is offering. And so before COVID, I was actually thinking that I was going to go to work for OSER as a remote engineer, to where I would just design stuff, and then when it was time for show and tell, hop on the airplane, go show them. Then they would, market it and all that. In fact, part of the reason why I got rid of a lot of the complexity of this and kind of turned it more into what it is now is I had the offer from OSER that if you develop a mechanical device that does this, and this, has grip patterns, then we will partner with you and we will spend the money to bring it to market. So then I did that. I developed what I have now, and then we got into the thing with the attorneys and the accountants. And the attorneys and accountants determined that there wasn't enough ROI in it for the company to expend that type of resources. Because I mean it's like $2.5–3 million that they'd end up spending in order to service the needs of really a pretty small market sector. And I mean the big problem is if you aren't missing all four at the metacarpal level, then this device isn't suitable for you. If you're just missing 2 fingers, you aren't going to want to wear all this gear for this. If your gesticulation is through the palm, then you don't have enough leverage in order to drive this device. Your lever arm. So it's for a very select market sector. It's for a very select type of amputee. So with that, it isn't worth the investment for the big companies to offer it as a product. I mean, I tried, going through the route of this, but, it wasn't penciling out for anybody. So then at the end, they're like, well, if you develop it as a market and you prove its market viability, then we'll partner with you and we'll bring it into clinic. And I'm like, well, if I'm going to do that, why do I need it to be in clinic? Why don't I just sell, directly to the public and just try to do the best I can for making sure that, anybody that buys this is going to be, truly a viable candidate for this and go that route. It's like if you aren't wanting to help me out at the early part of, getting legs underneath it, why should I decide to partner with you on the tail end of it? No, I'm not going to do a thumb. A thumb adds huge amount of complexity because a thumb is actually 2 axes. So how are you going to control positioning and angular degree for acquisition on a thumb? You'd end up having to do Bowden cables going up your arm and then harnesses going to your waistband, or shrug harnesses or that type of thing for the thumb. So no, this device is only for disarticulation at the metacarpal level, index through pinky. So XYZ, it doesn't matter what you call it, it's what its intended purpose is. So the big reason why I'm not so I am offering it as raw parts. And the reason is primarily so I can offer it as a project/product to amputees at the lowest cost that I can. If I start if I start finishing them and drilling the holes and tapping the threads and all that, absolutely I could do that as a machinist. But it takes about 40 hours to put one of these all the way together. So I get $150 an hour at the shop, and I'm going to charge the $6,000 that goes with that. So now you're taking something that was $6,500 and you're adding $6,000 onto it. So now all of a sudden it's $13,000. So if someone can afford the $6,500 and they have time, there's nothing magical about what I'm doing that would preclude somebody from being able to fit and finish and drill the holes and tap the parts. Might as well have them do it and save themselves $6,000. That's going to make it more readily available to more people. Because if you're looking at, I got to spend $6,500 or I got to spend $20,000, there's a big difference between those two. Oh, absolutely. You don't have to tell everybody, but if I were, so for me, if I was making these for local people, how would you know about it if I weren't advertising it on YouTube? So in order for me to get it out to more people around the world, I have to advertise it on YouTube. Well, if I'm advertising it on YouTube, I can't just do the shoot, shovel, and shut up method of getting things out. I'm opening myself up to liability if I were to be offering it as a completed device. So, there's a couple things that I think we're getting kind of, murky in the waters on that. So the UK doesn't have the same regulation and laws, but okay, so Joel has been doing open bionics for over a decade, and he might this year become profitable. So you say that, all of these people are doing all these things in the UK. If you're being subsidized, you're not doing it alone. And the only reason why he's able to do that is because he's taken a tremendous amount of investment through investors. And, after a decade, he might be profitable this year. I don't see that I have 10 years to maybe become profitable. So, but, I mean, you are more than welcome to take your energy and your ideas and start designing and developing for amputees. In fact, I encourage you to start designing and start building parts for others to help people improve their lives. Absolutely. So Philip Edwards, I've looked at doing the workshop method, of what you're suggesting, and my insurance company hates that idea because now you're having unskilled visitors come to your industrial location and they're going to be using all of your tools in order to do something they're unfamiliar with. Insurance does not like that at all. But yes, you could absolutely do a on-site workshop type thing. And I've considered doing that a couple times, but my insurance is like so against that. Well, okay, so would I be fine with a company owning the rights to my inventions, but I direct the time of engineers? Um, the ultimate problem with that is there isn't enough return on investment for anybody to do that. There just isn't. You know, out of the $6,500 that I'm charging for these parts, you know, you got to figure if I were to charge enough to where somebody else would be interested in doing this, then that raises the cost that somebody's going to have to do private out of pocket pay. So now all of a sudden $20,000. I mean, I don't know your financial situation, but if you were missing a hand, would you out of pocket come up with $20,000 to build a device? And what type of impact would that be if instead of $20,000 you had to come up with $40,000 because now I chose to have some investor group get into this so that I could license and have it done by somebody else. It does more damage to the. Okay, so I don't know when that died, but it did. You bring up Alt Limb Project. This last year, Osir and Autobach got congressional legislation to where prosthetic device needs to be run through a clinic that all finished prosthetic devices need to be run through a clinician. And that's because projects like Limitless Solutions were servicing too much of the market and taking too much of a bite out of Arm Dynamic, Open Bionics, Osir's pocket. Limitless Solution is able to build and distribute a device for in the $15,000 range, when through clinic it would be $100,000. So they went and got a couple laws passed to where any finished device needs, in the name of consumer protection, needs to be run through a clinic. So it's a terrible disservice to amputees. So I would totally. They're all going to screw you. All insurances are going to screw you. Yes. So, that's the U.S. The U.S. is not the U.K. So why electric or why mechanical and not electric? Because this is as fast as my natural hand. It doesn't run out of batteries. It doesn't care if it gets wet. It doesn't care if it gets dirty. It's way stronger, much more durable. A myoelectric hand is 1 second to open, 1 second to close. A myoelectric hand can maybe do 5 pounds, 10 pounds at the most per finger, whereas I have a video of me picking up 110 pounds with this device. So way more durable, cheaper to maintain, cheaper to operate, way stronger, just overall better. So, as great as the UK is, XYZ, there are a lot of negative things that I hear about doing business within the UK. Primarily, VAT, import-export tariff, just getting the product, just getting the raw product into the country, where we don't have to deal with that in the US. I have to ask, are you an amputee, or are you just super on this? Because you're talking about these things like you're someone's in vested interest. So, are you an amputee, or are you just talking from the sidelines? No, I have not built for single digits. There's for a single digit design, I would go with Naked Prosthetics, MPC, or DIP driver. That market sector is already pretty well. There's already a device in place for that. Same thing as why am I not doing through the wrist or transradial? Because there's already devices in the marketplace for that. Where there's not devices is disarticulation at the metacarpal level. Okay, but so XYZ, there aren't a bunch of myoelectric options, not for partial hand. For partial hand, there's one option for partial hand for myoelectric, and it's an Oser iDigits Quantum. And as I've said, mine was billed out for $85,000 through my insurance, which if I had to private pay that, I absolutely would not pay the $85,000. It's and it's $5,000 per finger to have it repaired. Or you can pay $300 a month for the insurance, and you get one tune-up and one fix per year. It's incredibly fragile. It's not a great project or a great product. So you have an amputee friend. I'm assuming in this sector that you have a 3D printer. Are you designing for your friend? Because that's really what needs to happen within, this area of the world. Right. Well, the reason why transradial and transhumeral devices haven't changed for the body powered is they work. I mean, they're simple. You're using a bicycle cable to actuate a voluntary open split hook. I mean, it's pretty simple. As long as your socket fits you, and you're getting good interface on that. I've built all kinds of tools for amputees that just click into the quick change, wrist. I've built all kinds of things for people, but they're specific use devices. So, that's the big reason. Occasionally you'll see someone, who is it? It's something cowboy on on TikTok. He's transhumeral. His gesticulation's about middle of his bicep, and he built a socket and elbow. Him and whatever clinician that he's working with, uh, they've made a pretty good. I think it's Space Cowboy maybe, um, and they've done a wonderful job. But again, like with that, there's not any market for it. It's him, and that's it. He's not getting into the marketplace, into the business of making multiples of it, because there isn't enough market sector to justify, building it as, building it for a bunch of people. Exactly. It's durable, easy to repair, and low number of components. Right. So one of the biggest things that I found, like with OSER, Arm Dynamics, and Autobox, I mean, I know I keep throwing those three under the bus, but nobody that is designing for this market sector is actually an amputee themselves. Nobody at OSER, I shouldn't say absolutely nobody, but the percentage of people that are amputees that are working for OSER in the upper limb. Okay, so in the upper limb product development team of OSER, nobody is missing parts. So how can you design for a world that you don't live in? You have no real idea of, what it's like to, be missing parts. So it's really hard to design for that. I mean, it'd be like me designing for somebody that is, below the knee amputation. I have no idea what it's like to be a below knee amputee. So I have no real right to go and try to design for them. Same thing for upper limb. And you bring up a good point, tested by people that need them, and every amputee and amputation is different, and they all have their preferences. Like I was saying earlier in the live, Moises Alejandro, he is a brand ambassador for OSER and has been for better than a decade. And he's been on my Patreon for, he's been a contributor on my Patreon since basically the beginning. And I've offered him several times, to get him a kit, make him gear, whatever. And he's like, I have what works good for me. And, I have no real incentive to want to change. He's comfortable with how his device works, and, you trust it and it works for you. So, that's what I'm finding a lot of within this trial is, I'm looking for someone that is right in that sweet spot of just lost their residual limb and they're healed enough to where they can actually wear a socket, and that they aren't going to be doing damage, they aren't going to be creating keloids or nerve or scar tissue damage, and they haven't settled into a set of gear that they're comfortable with. So timing is really all about, where you're at with this type of thing. So, all right. Okay, I'll give it two more times. I'll give it two more times of it disconnecting, and then consider that it's telling me that my live is done. So XYZ, you're wanting to design parts for your friend. You need to ask him what him, her, whoever, what they want as far as a device, and what would improve their life the most. Prosthetic devices are incredibly custom. What works for one person will not work for another person. So, and that's part of the issue with trying to commoditize or commoditize a device like this. What works for one person isn't going to be ideal for somebody else. So I would get with them and I would figure out exactly. All right, I'm going to call it for tonight. I've been kicked off too many times. I'll maybe try later on, tomorrow, maybe Sunday. Have a great night, everybody. Thanks for watching.